So, templates are one of the most important concepts in CSI 41. And it's something that you've been using already. You've been doing it all along without maybe even knowing it. So what is a template? A template, I guess the best way of thinking of a template is like a Mad Lib. And let me give you an example of templated code, and then I'll explain the analogy. So let's say that I was wanting to write a function called like add, and it's going to take in an integer x and an integer y, and it's going to, return x plus y. Okay, cool. All right, so we can see out add 2 plus 2, and anyone want to guess what this is going to print when I run it? Five, very good. ChatGPT. 4. Okay. But then let's say like, I want to make a version of this that works on, strings. You can do that. Copy and paste, edit, and that's fine. And then we could have an add that works with hello. If you add 2 strings together, it concatenates them, right? Hello world. And then it'll print out hello world. Cool. And then let's say we're going to make a version for like floats. And then we can like y3y and cw and no, cw failed, float, and then cw float. No, not ifloat, it's not iCarly. And then float, and then we want a version for double. Oh lord, not doubles, no. Double add, double this, and oh my gosh. We end up copy and pasting this damn thing so many times, right? And it's all the same code, right? It's all the same code. Now let's say it was a little bit more complicated than this, and we had a bug in our code. Well, shoot, now we got to fix this thing like in every single place where we've copied and pasted it. My lord, it's a disaster, right? So rather than doing that, what we can do is do something called a template. And the template class T, this T here is a fill in the blank. It is a fill in the blank. And so rather than int being here, it is a fill in the blank type. So T is short for type. And so we can have a add, this should probably be like a const reference just to be a little bit more correct here because we're not changing the parameter. And so if we use templates, we can write the function once. And what this does is it makes one version of the add string. It makes one version of the add function for us for int, and one version of the add function for us for string. And if we make a new one for floats, 2.0f and 2.1f, then it does the copying and pasting for us. So when you do this, the compiler says, oh, you're calling the add function. T here gets past this type parameter. So it's going to copy and paste all of this code, and everywhere the letter T appears, it's going to put in int. So what the compiler does is this. It literally does this if you have a template. And it does this for you automatically. You don't have to do it. I'm just showing you what it does. So that T turns into an int, and that T turns into an int, and that T not wants, and that T turns into an int. And that's what it does. So whatever type parameter you put into these angle brackets here, and like I said, we've been doing this all along. We've been doing this ever since vectors in CSI 40. That int gets passed in there for the T, and it copies and pastes the code, and it fills in int everywhere there was a T. And you don't have to do it. It does it for you automatically. And then it will copy and paste a version, filling in float for T, and it'll copy and paste the code and fill in string for T, and it's beautiful. So if there's a bug in your code, all you have to do is change it one time, and it changes in all the different versions, and everything is great, everything is happy, everything is awesome. Do we need that f and s after the parameter we're passing in? So the f means that it's a float. Okay. If you don't have the f, that is a double. If you have a decimal number, it defaults to be a double, not a float. So if you specifically want to do floating point arithmetic, then you put the f there to indicate you're doing a float. And then the s indicates that it is a C++ string, not a C-style string. By default, hello and world are C-style strings. And C-style strings do not have a plus operator on them. Only the C++ string class has a plus operator defined on it. You can concatenate two C++ strings together by using plus. You cannot do that with an old school C-style string. And when you just have hello and world like this, that is a C world string, okay? And so putting an S after that makes it a, like here, watch this. C out, hello, plus world. Doesn't compile. Because this is a C string. The C string does not have, like C doesn't have operators. Operators were introduced by Bjarne in the early versions of C++. So you cannot define a plus operator on C-style strings. They don't have operators. And so if you want to make it a C++ style string, then you add the S there to indicate that it is a C++ string, not a C string. Yep. Somebody should make a C minus minus. So for a float, it wouldn't suffice with just the prepended float. So if you, so check this out. If C++ can figure it out, you don't actually have to put the angle bracket float here. If you do that, C++ will look at the types of the parameters here and says, this guy here is a float, that guy there's a float. So we are doing float, and it will fill in float for you. All right. This won't work if your parameters are of different types. So if you've got a double and a float, the first one's a double, right? 2.0 is the double, not a float. The first one's a double, the second one's a float. It's like, I don't know. Or if you have an int and a float, it's like, I don't know. What, you know, do you want this to be doing integer arithmetic or floating point arithmetic? I don't know, man. I don't know what's going on here. So you would have to tell it, you would have to say, all right, I want to do specifically integer arithmetic, right? So if you have 2.2f and 2.1f, it's going to be doing integer arithmetic on them, not floating point arithmetic. It's going to be returning an integer, not a float. It is not going to return 4.3. It's going to return 4. Okay. So you can tell it what type. You can like force it to be an int if you want that way. Or you can make it a double, and then these floats will get turned into doubles. Okay, and we got 4.3 this way. So the reason why I was warning was because there's absolutely no reason for you to be doing this, right? Because all that extra precision you have in there is getting thrown away, right? You're passing 2.2 and it immediately turns into an int and becomes 2. It's like, why would you do that? Like, why? Like, that doesn't make any sense, man. Are you sure? And so it throws a warning at you if you're doing that. So, yeah. And so if you have the same thing, though, in both of these parameters, it'll just figure out, oh, it's a float. Just like here, like we don't need int. It'll just figure it out because both these things are ints. Both these things are floats. Both these things are doubles. Fine, it'll figure it out. Here, though, yeah, here even it'll work. Boom, because they're both strings. Now, the reason why I had that, though, is because if you do this, this won't work. Because, remember, there is no plus operator on a C world string. So in that case, you could do this and make them both. This will convert them into C++ strings. You can do it that way. Or you could do it this way and make them C++ strings to begin with. Okay. So this is the return type. Yeah, the return type is going to be, like for this guy, the return type is going to be int. And then it takes in an int x by const reference and an int y by const reference. And then for this one, it copies and pastes it. And it takes in a double x by const reference, a double y by const reference, and it returns a double. Okay. So the best way of understanding this is through the concept of Mad Libs. I don't know how many people know Mad Libs. Let's try this. Ooh, that's way too many. Zelda. Sure, let's do. Oh man, that's a lot of stuff. Man, that's way too much. Way too much investment on that one. Video games, why not? All right, let's just do it. I don't even care anymore. All right, so people type some adjectives onto chat, and we will do a Mad Libs, because this is actually a great analogy for how templates work. So templates have a blank, and you fill in the blank with a type parameter. So adjective, stinky, sussy, scrungly, funny. Nouns, give me 4 nouns. Bear, tree, egg. Need one more. Batman. Number. Somebody give me a number. 6. Done. 2 body parts. Arm. Tail. Okay. Plural noun. So give me 4 plural nouns. Appendices. Rats. Chips. Meese. Verb. And then a verb ending with ing. A gerund. Speed is not a verb. Running, farting. So we'll say run and then farting. There you go. All right. So what happens is there's like a blank, and that's kind of what the what you can think of the template as. It's like somebody left like a giant like fill in the blank there, right? So you've got like this giant fill in the blank for where the type is, and the user just kind of comes in, like if you want to think of it this way, right? The user just comes in and writes into the blank int, or float, or double, in and out, string, right? So it's literally like a Mad Lib where the user just fills in the blank. And why do we say T? Because T is template and a type, and it's convention. Like, why do we always use I for int? I equals 0. You just do. It's just convention in computer science. And if you've already used I, then you use J for the next one. Then you use K for the next one. With templates, you have T and U. So if you wanted to, you can have 2 different types for the first parameter and the second parameter. Then you can mix and match like a float and a double like this, and it works fine. The return type here, is the return type going to be a float or a double? What do you guys think? So I'm passing in a float for T and a double for U. So X is going to be a float. That's going to be a double. If you add a float and a double together, it's going to give you a double. It's going to be a float. Yeah. Even though this is a double, because we used a float for T, the return type is going to be a float, and it's going to narrow from a floating point number down to, from a double to a float in the return type. Because this parameter here is a float, so T is float. It's a fill in the blanks. You filled in float for the first one and double for the second one. So even though you're adding a float and a double together, because you declared the return type, it's as if you had written here float, right? As if, it's as if you had written that. It narrows from a double to a float. Okay, so let's find out how our thing turned out. I love to run video games. I can play them day in bear. My mom and tree are not too happy with my farting. Fair enough. So much time in front of the television, egg. Although Dad believes these stinky games help children develop hand-arm coordination. That's actually not too far off. Hand-arm coordination. And improve their learning appendices. He also thinks they have sussy side effects on one's tail. Interesting. Both of my rats think this is due to a scrungly use of violence in the majority of the chips. Finally, we all arrived at a funny compromise. Worked out pretty well. After dinner, I could play 6 hours of video games, provided I helped clear the Batman and wash the moose. It's pretty good. It's pretty good. Somebody get the Batman. Sussy side effects. Yeah, that was amazing. All right. So we can. Do you guys understand this with functions? So rather than having to write all these different functions, we can write it once, and then that puts all of our code in one place. If there's a bug, we only have to fix it in one place. The compiler does all of the annoying work for us, copying and pasting. It's not actually that slow, even. Like, the only real downside to using a template is that it causes the compiler sometimes to have really obnoxiously bad compiler errors, right? Like if we did this, let's see if we can get a bad compiler error from it. Nope, not too bad. No matching function call. Given 2 constant char stars. Not too bad. Not too bad. Template substitution errors, though, can get pretty bad. Back, scout, back. So we try scouting a vector, which most people try doing at least once in their lives. Try scouting a vector. You will get errors. You will get errors for days. It's a lot of lines of errors, and they're actually not even errors. They're notes, which is even worse almost. You get 429 lines of errors if you try printing a vector to the screen. So this is the downside to templates, is that the compiler is trying to substitute different things to make it work, and it doesn't work, and it tells you every time it tries something that doesn't work, and you don't care. You really don't care, but it tells you anyway. So, so like I said, we've been using vectors with templated vectors all along, right? Could we do this? Could we just say a vector named vec? Is it able to deduce which type of vector it should be? Can the compiler figure out, is this a vector of integers? Is it a vector of floats? Is it a vector of doubles? Can it tell from what we have on the screen there? Scrungly men are usually taller than average. No, it can't, right? And that's why all along we've been just saying a vector of integers, right? Or we'll make a vector of strings or something like that. That is the type. That is a template type parameter. We have been using templates all along. We haven't been writing them. We've been using them. But what if we did this? What if we made a vector named vec and set it equal to a initializer list of integers? Can it figure out what kind of vector it should be here? Can it deduce what kind of vector we're wanting? Yeah, it can. It's going to deduce the type of vector it is from the right-hand side. And if this sounds a lot like auto, yeah, auto is actually, if you want to see something cool, that works just fine. And what is happening here, it's actually making a template for you. So this is actually a template. Now, the auto that you might have seen before, where you say like auto x is equal to 5 or something like that, this is not a template. It's just, well, I mean, it sort of is. It's like type deduction. It's deducing the type of x from whatever is on the right-hand side. And so here, the type it's deducing is based on the right-hand side. It's very similar to auto. It's a little bit different technically, but it's basically what's going on with auto. It's like, can I figure out what kind of vector I should be? And you look at the right-hand side, you're like, oh, those are all integers, right? But if any of these things are like not, like if you have like a, I don't know, float in there or something, it won't work. Because now it doesn't know, right? It's like, I don't know what that's supposed to be. But if they're all the same thing, It's like, okay, I'm supposed to be a vector of integers. Got it. Right? But if these were all like, I don't know, floating point numbers or something, sure, they can figure it out. I'm a vector of doubles now. Cool. And you don't even have to change anything over here, right? And if you make this a double, then x is now a double. It deduces the type from the right-hand side. It's very common. And so the auto add function, you pass in a float and a double, would it return the double? Yes, because it's going to deduce, it's going to copy and paste a version of add with a float as the first parameter, a double as the second parameter, and it deduces the return value from that. So if you add a float and a double together, it gives you a double, and so the deduced return value is double in that case. So auto just figures it all out for you automatically. And you don't even have to have this syntax here. And this is the syntax for today. So the learning point for today is template. Okay. So there's two ways you can do this. Let's just put it back at the earlier version here. Okay. So there's actually two ways you can type this. It's a bit of a pun. So you can either do it like this. This is option 1, like that. Or you can do option 2, like that. Learning point for today is called template. And so students will sometimes ask me like, well, which one should I use? Should I use class T or should I use type name T? And you will see me almost always using class because it's less typing. Ironically, again, it's a pun. It's less typing than type name. There is no difference to the compiler. The compiler treats both class T and type name T identically. There's literally no difference between the two. For some programmers, they would expect you to be passing a class here. Like when we're passing in a string, like if you type in class T, they would like maybe expect you to be using it with classes. Whereas maybe if you did type name T, it would be expecting it more with like ints and floats and doubles, but really, nah, there's really no difference between the two of them. There's really not. So I use class T for basically everything because it's 5 letters instead of 8. So that's my reason for it. I'm sure you'll find somebody who says, well, type name is better because it's more accurate or something. I don't know. People get mad about everything. I legitimately don't care. Anyway, 2 options. They're identical options. Okay. And then this is a third option here. Down here, option 3, use auto. And this is, I think, C++ 20, actually, was when I think full auto worked. I think there might have been a limited version of this in 17. G++ dash std equals C++ 17. 60. Warning, yeah. It doesn't work in 17. It works, but it doesn't work. And then if you do 14, do I have insert mode on? Doesn't work. And you can also see in C++ 14, it can't deduce the type parameter here. So type deduction has gotten better in the last couple iterations of C++. It would deduce it on some things, but like other things it wouldn't be able to deduce. And then if we take it back old school to like 98, auto doesn't work anymore. The type deduction doesn't work. You can't declare X with no type. Yeah, there's a lot of, like, the further back you go, the less of this actually functions. But this is like C++ 20, which is the latest standard, and it allows you to write templated functions really nicely. Really, I mean, it's really quite nice to look at. It's like, cool. This function here can add any 2 things. Neat, and it'll just figure it out. So you said people use T and U, but the Zybooks say they call things like type. Is a convention to use T and U, but you call it whatever? No, in professional programming, everybody uses T. The Zybooks might call it type to not confuse people or whatever. But I don't know. Let's example of template Fibonacci sequence or something. Let's find some crappy Geeks for Geeks or something. C++. This is so bad. Template, long number. No, that's a. This is okay. That's actually hard. That's something different. Example of template C++. Yeah. See, here's Microsoft T, right? And if you have two of them, T, then U, right? Stack Overflow H. That's just heresy right there. You can't use H. What's this H stuff? It probably means something like hash table or something. CPP reference T. Like CPP reference Microsoft. Like everybody uses T by convention. It's not a rule. Like, I mean, you could call it type. Cybooks, calls it type. That's fine. Like, and they probably do that because, like, just calling it T would like confuse people. Maybe, I don't know. So you can do that. Like, there's nothing wrong with this. It's all good. Type name the type. Yeah. Whatever you want to call it. It's fine. Why do you hate Geeks for Geeks? That's so bad. I have found so many mistakes and things on Geeks for Geeks. It's just like, oh, yeah, no respect. No respect for that site. Yeah, just don't call it H. I don't know what's going on with that. Like, maybe if it was like a hash table or something, H makes sense. I didn't look at it very closely. But yeah, basically the convention in computer science is to use T. That, you won't be questioned. Anytime you see code that's templated and you see a T, everybody knows that's the substituted, that's the Mad Lib, right? That's the Mad Lib. That's where, somebody wrote down and they filled in the blank. Anytime you see a T, that's a fill in the blank. They're going to angle bracket string and string's going to appear there. You guys get what I mean by Mad Lib? Like it's a blank and you write the thing in. It's not always the type on suffix either. It changes. Yeah, okay. Yeah, and to be fair, like, it's probably more readable this way. Like, let's be honest. Like, it's probably more readable to do it this way, right? Because nobody knows what T means unless you know templates. Like, you don't know what T means. And so for a first-time template programmer, yeah, you can do it like this. It's fine. I really don't care. I mean, style things like that just really don't set me off like some things. All right. So the other thing you can do with templates is template a class. And this is huge for data structures, right? So if you're going to make a list class, you could do template class T, class linked list. And we could have a data of type T and a pointer linked list pointer to next and a linked list pointer to previous. And so now we can make a linked list to anything. So we can make a linked list of integers because that's usually what we start with. Usually when we do data structures, we just worry about holding lots of integers as sort of our vanilla ice cream of data structures. So if we do this, then every node in the linked list is going to hold a integer called data. But rather than needing to copy and paste this, right? Like what we had to do before was come in here and like 1, 2, 3, 4, 5. Yeah, before we'd have to Y5Y, Shift P, Y5Y, Shift P, there we go. We'd have to come in here and change this to be an int, and then Y5Y and T, and change that to a float, and we'd have to redo all. Forget about it. It's like absolutely terrible. So rather than having to make a linked list for ints and a linked list for floats and a linked list for strings, and a linked list for doubles, and a linked list for charts, and a linked list for booleans, you don't have to. You just have to make a linked list once, and you make a linked list that sort of encapsulates what it means to be a linked list. You're not worrying about the type that you're holding. You're worrying about things like prepend and append and delete from the middle and things like that. Like, what does it mean to be a linked list? You can push front, push back, pop front, pop back, size, iterate across it, that kind of stuff. without having to worry specifically about what kinds of things you're actually holding in your data payload. Does that make sense? That you can actually just really focus on, like for adding, right? Like we don't care anything about the type here anymore, right? We don't know if we're adding doubles. We don't know if we're adding strings. We're just focusing on the essence of what it means to add something, right? This is what it means to add something. Take X, take Y, put a plus between them. There we go. And so if you make a linked list like this, then you have every linked list now. You can make a linked list of strings, right? Like you can make a linked list of anything. And that's why all of the standard library stuff is called the standard template library. So the standard library used to actually be separate from the standard template library. The standard library included things like square root and pow, and there wasn't a string class. Like when I was taking this class, we had to make our own string class. Like we spent half the semester or the quarter making our own string class because it was that useful. The standard template library was a completely separate project where they were building general purpose linked lists and vectors and strings and things like that. And then eventually it got merged into the standard library in '98. And then we've had vectors and strings ever since, which has been really nice because C-style strings suck. They are really garbage. Like it's actually really, really annoying to work with a C-style string. And so, like you saw, like you can't add them together, but there's a lot more you can't do, and you cause buffer overflows left and right, and things like that. And so just being able to do this, like just being able to have a linked list that can hold anything is really nice. You know, it's really nice. Yeah, it's like if we wanted to make a vector, you know, if we want to make our own vector class, we could be like pointer, something like that. These are all private. Whatever, I'm not doing anything with it. Right, and then I could have a constructor, vector constructor. Let's just make everything public. Who cares? Vector constructor could like, I don't know, like R equals new, not new int, a new t, size 100. I don't know. And then the destructor. We got a new. What do we need to put here? So we're gonna. It's like whenever we make a vector, we're going to allocate 100 integers, not integers, 100 whatevers. What do we need here? Delete or delete square bracket. We're going to do delete R. Delete and delete square bracket are actually two different commands, even though I think they shouldn't be. They are. Because an array, it is an array. We did a array allocate here. So this is an array new, so it needs an array delete on it. And then we could write a getter, tget. And we can even default initialize all the elements in there by use open and close curly braces. That initializes the whole array for you. Cool. And that'll work if it's an integer array or anything really. Semicolon there. And avoid set index and const t reference value. And so we'll set array index equal to value. And we can even return this by reference. And that is at least the beginning of a vector class, right? And so we could do something like this. Vector of ints named vec dot set index 42 is going to be set to be 10,000. Cout vector dot get 42. What should this print at the screen if we did this right? And we were named not vector capital V. There we go. Okay. Old habits, right? So what value is this going to print to the screen? Run out of coffee. We're going to have to bring lecture to an end now. Oh, wait, no, sorry. Backup coffee. It's almost a disaster there. 10,000 it is. Okay. And we could add bounds checking here, right? You know, if index is less than 0 or index is greater than or equal to 100, I probably should have this be a const static int size equals 100. I don't have any magic numbers in my code. If that, then we will, I don't know, throw runtime error. No, you're out of bounds. Okay, so if we do that, we're fine. But if we try setting 420, then it will throw an exception. So we do a little bounds checking up in here. If we try getting element 420, it'll also throw an exception. So this is not a terrible way to begin. You know, obviously we would need to do things like add pushback and stuff like that, but this is like a decent way of beginning a thing. Now we could also make a vector of strings using the same code. Look at that. I didn't have to rewrite anything. Isn't that amazing? I didn't have to change any of my code. My vector code is all exactly the same. I didn't have to do anything to support holding a vector of strings. None of the code above it changed, right? Isn't that cool? Vector.set element 10 is set to be hello world. And vector element 20 is set to be goodbye world. And I could see out vector.get 10 and vector.get 20. What's that going to print? Hello world, goodbye world. Boom. And there it is. Do you guys see how useful that is? Now, some people get confused, like when should I use inheritance? When should I use templating? And my advice is try to use templating whenever you can. Inheritance is good whenever you have an is-a relationship. So if you have a student class and a student class is a human and you've got like some sort of human class, and the human is a mammal and you've got some sort of mammal class, and a mammal is a animal, you've got some sort of animal class. And there's some things that describe animals, like they've got a location, a weight, you know, whatever. And there's some things that describe a mammal, like having hair and milk and stuff like that. And there's some things that describe a human, like you got 2 arms, 2 legs, you walk upright. And you got some things that describe a student, like they're enrolled in a college and they get grades and things like that. Like if that's sort of the relationship of like the objects you have in the world, inheritance makes sense. Anytime you have a has a relationship, though, templating is usually the better way of going, right? So is-a, use inheritance, and then has-a, use composition and templating. So for example, a vector has a int contains, right? So every time you set something, maybe, I don't know, it increments the count, or, you know, maybe the slash should start with size here. And that's like how big it is currently. And if you call pushback, if contains is now bigger than size, then you have to reallocate it and stuff like that. And maybe size should actually be resizable if we're going to make it a vector where you can push back into it and things like that. So this is a has-a relationship, right? So every vector has a size, right? Inheritance is used for is-a relationships. A student is a human. A human is a mammal. A mammal is a and animal. Do you guys see the difference here? So if you have a member variable, that's a has a relationship. And oftentimes templating works really nicely with that. So you can hold different kinds of things like this guy here, private. Every vector has a private array, right? That's templated. And so it just kind of depends on like the problem you're solving. I don't know if that makes sense. Does that make sense to you guys? Like, if you've got a shape class, and it's always shapes, I hate it. But like, you know, you got a class and you want to make a copy of that class that's slightly different, then inheritance oftentimes is the right solution. I'm not saying I hate inheritance. I used to hate inheritance. I don't hate inheritance anymore. I just, I don't like it. I don't hate it. I just don't like it. Having to use pointers for everything like just makes everything like an extra level of indirection, and the compiler errors you get when you have an extra level of indirection on everything are not as useful. Like a lot of students had code like this, like vector.pushback, shared pointer to a actor, something like that. And like their actor class had a 2-parameter constructor, not a 1-parameter constructor. If you were doing this with just like a regular actor, like if you had a vector of actors and you try doing that, it would tell you correctly you don't have a 1-parameter constructor. You'd get a good error message. When you have a shared pointer like this, the error message we were getting was pushback doesn't exist. Could not find a matching pushback function. And that's kind of wrong, right? But having that extra level of indirection from having to use pointers to make inheritance work causes the error messages to become much less valuable and oftentimes mistaken because they're pointing to the wrong part, ironically pointing to the wrong part that it was saying pushback is wrong. And the reality is you didn't have the right number of constructors here. So I dislike inheritance, but there are times when it's the right thing. If there's a relationship, inheritance is kind of the best match for it. Whereas has a templating and composition, member variables is kind of the right way. Okay, so that is my lecture on templates. They are useful, and pretty much for the rest of the semester, anytime you make a data structure, it's probably going to be templated. I don't know, like if you're going to make a stack or a queue, like just make it a template. So your stack and queue works with anything, not just integers. So it takes one extra line of code, and then your code works with anything. It's really nice. All right, that is our lecture for today. Make sure you guys get the coding competition done by Friday. It's not a hard assignment. It's after RPG 41, I kind of wanted to give you guys something that swung back to kind of the easy side to recover your strength. Let's do it on Friday. Start class at noon, and then we'll do something hard again next week. Okay. Or did I say hard? We'll see. We'll see how it goes. We'll see how you guys do on the stacking queues thing, and then I'm kidding. EU4 is like a difficulty 6 out of 10. I'd say that's what Mancrelli and I are planning on doing next. It's more linked list stuff, but we'll see how you guys do. We'll schmedium, hardium. I don't know. We'll see how it goes. Okay, that's it, everyone. See you guys on Friday. Peace.